Mangram Hotel.
Oh, I'm sorry, I'm muted. I'm sorry about that. So I'll take the step again. So because I want to get a text file or a CSV file, I'll go to my my Power BI interface, and I'll go to get data. I'll go to text or CSV file. So because I recently opened this file, it's already here. So I don't need to search for it. It's among my recent file. So what I was saying was that CSV file, you cannot have multiple CSV file in one Excel workbook. So I didn't believe it's an Excel workbook now. I can import everything at once. Then I can select the ones I want out of all the data sets. But because these are CSV files, except you convert a CSV file to an Excel file, that's when you can have multiple CSV files in one workbook. And in that case, no more an Excel file. There's no more a CSV file that has become an Excel file. So you can only have one CSV file in one Excel workbook. So I'll be importing them one after the other. I'll import the categories. I will open. And once it is opened, I will use my transform data. So I can actually load my data or transform my data, but I'm using the transform data option. So the essence of using the transform data is that you want to clean your data in a particular way. If you are sure your data is clean, then you can just load directly. And one best practice is that even if you're the one that prepared the data and you have checked the data multiple times, you should still transform your data and double check, in fact, triple check multiple times to be sure that there's nothing to clean again. Of course, even while analyzing your data, if you find anything you need to clean, you can always go back to Power Query Editor to clean it. So I've imported the first file. So I'm going to import everything. New source, text or CSV file. I'll import the second one, customer. I'll open it. And since I'm already in Power Query, it will not give me the option of transforming my data again. So see, this is where I'm transforming my data. So there is no need for it to tell me to transform my data. Immediately I click on transform data in the first instance, it opened Power Query Editor. So we are now in Power Query Editor. And since I'm importing a new data from the Power Query Editor, what I just need to do is to click on OK. So I've imported the second data. Please remember to jot down your questions. So the third file is the employee data. I'll open it. Click on OK. I'll do the next one. Other details. I'll click on OK. The next one is others. Click on OK. product. Click on OK. The next one, shapers. Click on OK. So in all, we have 7 data sets. And the essence of these data sets, the essence of the class is to identify, is to model this data for easy analysis and visualization. So I would need to identify some things about my data set. So I'll go to the first data, which is the category. And before I start, I'll need to explain some terms. So there are some simple terms you need to understand about data sets when you are trying to model your data. So this is going to help you to understand how you are going to transform your data. Maybe you are going to drop some columns, you are going to expand some columns, you're going to separate some columns, split some columns, merge some data, append some data, do whatever cleaning as necessary. Do whatever cleaning as necessary. So another thing you need to understand whether a table is a fact table, whether a data set is a fact table or a dimension table. So a fact table shows a transaction, is a transactional table. It shows the day-to-day activity of a particular organization or a particular business. That is a fact table. It shows facts, day-to-day or day-to-day activities. That is a fact table. Then dimension tables, they are descriptions. They are just mere descriptions. So they usually contain description about products, description about employee, description about categories, about regions. But that does not mean that a description table or a dimension table cannot have numbers. They cannot have transactions. They cannot have digits. For example, a product table. A product table is a dimension table, but that does not mean a product table, being a dimension table, cannot have a product price. Of course, a product price in a dimension table may seem like, oh, this is the fact table because it has values. So a table having value does not necessarily mean it's a fact table. So you may not want to use that description or that to identify a fact table. I've seen many people say, oh, once a table has value, then it is no more a fact, it's no more a dimension table, it's a fact table. No. There are times that you find figures in a dimension table. Another thing is in a dimension table, you can also find duplicates, which is common with fact tables. Fact tables are the ones that have duplicates because they are transactional. They happens from time to time. Over time, they happen like that. So when you have a dimension table that have duplicates, that means there is a problem somewhere. Then you need to remove the duplicates. So to make it easier to understand, a dimension table is just okay, let me state this example. It's just like you going into a bank or opening an account with a bank. When you open this account with this bank, you have your details, your name, your surname, your email address, your phone number, the branch you are opening the account with, and some other information about you. Then you have your account number. You have your account number. In this case, as a customer to the bank, the customer data set is a dimension table. It is a description about you. No other customer in this world can have the same description as you, exactly the same. And if that happens, they are going to give you a unique identifier. And in this case, your unique identifier is going to be your account number. No other person can share the same account number with you with the same bank. So let's assume I use a bank. My neighbor used the same bank. we have the same name, we have the same surname, we are living in the same house, we have everything the same. Definitely, one thing is going to be different, our account number. We cannot have the same account number with the same bank. So in that case, in the customer's book, the dimension table, the customer's dimension table, the unique identifier is my account number, and no other person can have it with me. Same thing for a bank. For a bank, they have products. Banks deal with different products. So they have description about this product and everything that you need to know about this product. Then this product is going to have its own unique identifier. The same thing with the employee. They have their employee name, their employee address, and each employee is going to have its own employee ID or his or her own employee ID. There's no other ID from any branch can have that ID. So in this case, you may want to liken it with your matric number when maybe you're in the university, you're in the poly, or your student registration number. No students, even if there are other students that has the same name and the same surname as you, they're in the same faculty, they're in the same department as you, they cannot have the same matric number as you, except there is a mistake somewhere. Even if the matric number is almost the same thing, the year is going to be different. If the year is not different, the faculty is going to be different. If the faculty is not different, the department is going to be different. So these are things that makes up matric number in most universities. They combine your year, your faculty, your department, and your serial number to make up a matric number for you, for students generally. So another thing, so we have mentioned fact table. That fact table is a transactional table. So to explain more about fact table. So fact tables, so for every bank, we have the customer book, we have the product book, we have employee book, which are the tables that everybody's details is registered. Now, what differentiates fact table from all these tables, which are dimension tables? So immediately I woke up, I opened my bank app. While I opened my bank app, someone else also opened the same bank app and started transacting. I bought card, I bought data, I did my cable subscription with my account number at different times. So my account number, the number of times I log into that app is going to be shown on that app. So my account number is going to be repeated based on the number of times I log into the app. So it's going to be real time, and this is the transaction table. So this data set is going to be downloaded in real time, or it's going to be loaded in real time, and customers or people or whoever wants to work on it can have access to it. So that means my account number will not appear once in a fact table. It is going to appear multiple times. Today now, I know the number of times I've opened my app, you understand, for a particular bank. So let's imagine a bank now has multiple customers, millions of customers. Someone is working here almost at the same time that I'm pressing my phone and opening my app, and that person is also opening their app somewhere else, doing almost the same thing or similar things. So what differentiates us is our account number, even if we have a name. And our account number is going to be repeated multiple times in a fact table. So for example, this account number, that is the unique identifier for this fact table, is going to be multiple. Then this account number, remember that this account number is also going to show in the bank customer book. But the only difference is that in the bank customer book, it's not going to be repeated because the bank customer book is just a one-time recording of my details, just for the banks to do their own KYC. It's not transactional, it's not happening in real time. They just need to get their customers' information, and it's just going to appear once. It's just going to appear once. I hope you understand. It's just going to appear once. So, what is the relationship? What is the relationship between a fact table and a dimension table? What is the relationship between a fact table and a dimension table? So for us to be able to analyze our data well, and visualize it properly, we need to connect these tables together to give us a good analysis. Another thing is that we need to ensure query speed and query optimization. So it doesn't make sense for me to have a large table, which is a fact table, and every details is there. My customer details is there, my product details is there, employee details is there in one fact table. Why do I need to do that? Why don't I just break down these tables? And if these tables are already broken down, why don't I just have it, connect it in a way that they can interact with each other without any problem? Why don't I just make it in a way that they can interact with each other without any problem? So that is the essence of data modeling. That is the essence of data modeling. So we have talked about fact tables. Please, if you are confused, remember to jot down your questions. We have talked about fact tables. We have talked about dimension tables. We have talked about fact tables. We have talked about dimension tables. Now, we need to talk about primary keys and foreign keys. We need to talk about primary keys. So, for example, we are about to talk about primary keys and foreign keys. So, what is a primary key and what is a foreign key? What is a primary key and what is a foreign key? In your customer table, that's your unique identifier. Is your unique identifier is your primary key. Your unique identifier is your primary key. Your unique identifier, please hold on. So I'm sorry for the break. So in your customers table, your primary key, your unique identifier is the primary key. Your unique, for example, now in the customers table, your account number with a bank, your account number is the primary key there. So once your account number is the primary key, once that account number is now in the transactional table, once it appears in the fact table where the day-to-day transaction is happening, it becomes a foreign key there. Why is it called a foreign key? Because it is not native to that table. It does not belong to that table, but it needs to show in that table for identification so that the bank can link it to you. As, okay, this is the person that carry out this transaction. So your account number in the fact table is not a primary key. It's not unique to that table. It's not native to that table. It is not native to that table. So it becomes a foreign key in your fact table. It becomes a foreign key in your fact table. Same thing with employee ID. Once it is found in a fact table, it is native to the fact table. It is native to the employee table, but it becomes a foreign key in the transactional table. So we have talked about fact table and dimension table. We have talked about primary key and foreign keys. Now, to the application. To the application. To the application, we need to first, when we see a table, we need to first identify the keys. We need to first identify the keys. Once we have identified the keys, then we'll be able to say, oh, which one is a dimension table, which one is a fact table, and how can I connect them? How can I connect them? So now I'll be going back to my, oh yes. So this is our first table. This is our first table. Our first table is a category table. And this, we have category ID, we have category name, and we have description. The second table is a customer table. We have customer ID, company's name, contact name, contact title. We have the city, and we have the country. Those are the columns that we have there. So from the first table, we can see that these are mere descriptions. This is the category table. We have the category name and the description about the category. So beverage, we have soft drink, and the others like that. You can learn more about this since you have the data set and see more. So this category ID shows that once I'm talking to my co-employee and I say category 1, they already know that I'm talking about beverage. Once I say category 6, they know I'm talking about meat and poultry. So this is the unique identifier for this table. The category ID is the unique identifier for this table. When we go to the customers table, we can see customer ID and the others. We can see that everything here are descriptions. So this is another identifier that these two are dimension table. They are describing it another table. Let's now assume that you do not have anything called ID here. We used to be able to identify, we'll be able to know what the unique identifier is. We'll get to that. Employee ID, same thing. This is showing details about the employee, their name, their title, the city, the country, and who they report to. Other details. Other details as the order ID, the product ID, unit price, quantity, and discount. Then the others also has the order ID, the customer employee ID, order date, required date, ship date, shipper's ID, freight, and the other one like that. So I'm going to come back to the other details and the orders. Then the product. The product is also a description. You can see product ID, product name, quantity, unit price. So this is where I'm talking about that. Though the product table here is a dimension table, but we can see that it has some figures. So if you are using figures to identify what a fact or a dimension table is, you may be wrong. You may be wrong. Then the shipper has shipper ID and the company name. The shipper ID and the company name. The shipper ID and the company name. So now the first thing I would want us to look into is to go to under in our Power Query Editor. Let's look at the view options. So I'm going to turn on my column quality, my column distribution, and my column profiling. So for my category ID, I'll turn off some of it so that we can see what each one of them is doing. The column quality shows that this column has all the values, they are valid. There's no error and there's no empty. Once I turn on column profiling, you'll be able to see the profile of this column. And once I turn on column distribution, we'll be able to see all of this. So how do you identify which column is the unique identifier? Though you do not see category ID or do not see anything like ID, how do you know? So that is where you check out the distinct and the unique. The distinct and the unique. The distinct and the unique of a particular table. So I'll go to this place. I'll also go to this place. So for you to know which one is the ID or the unique identifier in a table, for a dimension table, like I mentioned, there is not going to be a repetition. It's supposed to be one value for all the transaction that is going to be there. One value, but there are times that there will be repetition in some instances. Then you need to remove duplicates, or it is just going to be like that. So for this place now, so let me quickly explain the difference between distinct and unique. So this is an example that I love to use most of the time. This is an example I love to use most of the time. The example is about a zoo. When you're in a zoo, you're supposed to have many animals, the wild animals and the domestic animals sometimes. So when you go to a zoo and you have 4 lions, you have 3 jaguars, you have 4 turtles, and you have 1 donkey. All of these animals, including the donkey, they are distinct. That means we have a donkey, we have a turtle, we have a jaguar, we have a lion. They are distinct identity. But out of all these animals in this zoo, only the donkey is unique. Only the donkey is unique. All of them are distinct, including donkey. All of them are distinct. That is, they all have they all have an identity. They are distinct. But which of them is unique? Only the donkey is unique. So in the situation where the unique and the distinct equals the same thing, a column that has the unique and the distinct equal, that column is most likely the ID for that column, the unique identifier for that column. And for a dimension table, most of the columns are going to have their unique and their distinct in the same value. So we can see here that for this one now, if I go here, the distinct and unique, because they are not supposed to have repetitions, the distinct and unique are still the same thing. And here too, the distinct and the unique is also the same thing. So that is one way to identify which one is it, apart from the fact that a dimension table is going to have descriptions, which may fail us sometimes, where we know that it may not be description all the times. It can also have values. So in case it have values and we are confused, we can come here and check. What about the description? What about the column quality? Is the unique equals to the distinct? Then from there you should be able to identify your dimension tables. So I'll go to the next one. So here too, if I turn on column quality and I column profiling, so we have distinct, and unique for this column as 9292. If I turn on this one, you can see that almost all of them have the same thing. Almost all of them have. So in this case now, for this, I'll turn on the column profiling. Sorry, the column quality, and I will turn on the column profile. So in this case now, we have 13 distinct and 3 unique. And we are still saying that, oh, this is we are still saying this is a dimension table. How come? Yes, it can happen like that. So in this situation, let me first transform my data and use first row as header so that we see it clearly. So I've promoted my header to have the right headers. So here now, if I go back to my view and I turn on my column profile, you can see that, okay, it wasn't this one. Okay, it was this one. So we can see that the distinct and the unique are not the same. So the distinct is 12 and the unique is 2. Why is it so? Yes, it's meant to happen. So what it means in this case is that for this column, there are 12 distinct identities, but only 2 of them are unique. So what does that tell us? What it tells us is that we have, let me use my filter. So we have account manager, assistant sales agent, assistant sales rep, marketing assistants, marketing manager. We have all of them here. But out of all these designation, it is all of them, 12 of them are repeated. Only 2 is not repeated. Only 2 are not repeated. 12 of them are repeated. And it is making sense because if you look at this data set, this is a customer data set. If this is a customer data set, so contact title, the title of the customer is, this person now is a sales rep. So anybody can be sales rep. Anybody can be sales rep. So this is the kind of this title that the customer has. So we can have a lot of customers that they are sales rep in their organization. That is their own job. That is their own job. They are sales rep in their organization. Some of them are business owners. So you can't say because one customer is a business owner, that means another customer cannot be a business owner. So that means it's not a dimension table. No, you need to understand the characteristics of that column. It's just like having a same column and you have a sales ID, sales rep ID, and many sales rep are reporting to a particular manager. So when you see the manager column has a lot of duplicates, like the manager is repeated, and it sure makes sense because so many sales rep will be reporting to the same manager. So 3 or 4 sales rep can be reporting to a particular manager. So that does not mean that table is no more a dimension table because the manager column has repetitions. You need to understand your data. So I'll move to the next one, employee ID. So it's all full of description. And we know that this is the ID for this. So same thing with other details and orders and products and shippers. So you just need to check on these 3 things to check what do they look like. Another thing you need to use to check if there are errors or there are null values in your data set. So once you check them, you'll be able to know the characteristics of your data set. So now to the real work. We have seen this data set now. We have seen this data set and we have understood that this data set has a lot of things like this. So now we want to model our data. We want to check which of this data is not necessary, which of it can we combine together such that we do not have to have unnecessary columns, unnecessary tables, and we have redundant data. Redundant data are data that are repeated and they are not necessary, and they slow down our query and our analysis. because they're actually not necessary in our data set. But for data keeping sake, we need to have them. And one thing you should also understand as a data analyst is that once you have a data set, the same way you not tamper with a database, do not say because this data set is in Excel, I can just decide to work with it anyhow. So I'll just start transforming. JB is in Excel, there's no problem with me. No, there's a problem. As a data analyst, it is best practice that you do not work on the original data set. Please always ensure that you make duplicates, because once you start transforming the original data and you feel it is not necessary, you feel this data set is in Excel, you start transforming it, there will be one information that you have cleaned, you have deleted, and that may cost you your job as a data analyst, or it may cost you a lot. So once you are given a data set, best practice, please duplicate it or make a copy of it and start your transformation on that duplicate. Leave the original data set. Do not clean an original data set. Do not clean an original data set. Make a copy, but because this is a fictitious data set, it's not, nobody owns it. You can work directly on it. So I have been able to identify my fact table. So coming back to the other details and the orders. Yes, my other details, I can see that. How do I identify the ID? Apart from seeing other ID here, how do I identify if this is a fact table or a dimension table? So looking at these two tables, I can see my order ID, my product ID. So this order details has all this information. My orders too has all the information. Okay, it's a little bit confusing. But now, looking deeper into my order details, I can see that it has order ID, it has product ID, it has unit price, it has quantity and discount. So this is obviously telling me that, okay, my orders this is the ID of my product, and this is basically telling me about the product ID, the unit price, the quantity, and is giving me the facts about my product, the discounts I'm giving for the product, the quantity of that product that they are buying, the unit price of that product, and the product ID. Of course, I need to have the product ID to know which product is giving which discount and which product they are selling at which quantity. So if I look at this table very well, I can identify that, oh, this is actually talking about products. Okay, now let's look about the order ID. I've looked at my order details table now. So the order tables, and I can see that, oh, I have the order ID, I have the customer ID, I have all of this. And I can say that, oh, this table has keys. This table has keys from other tables. This table has keys from other table. So it has the customer ID in it, it has the employee ID. It also has the shipper ID. It has the shipper ID. And it has other information. So with this, I should be able to identify that this is actually my facts table. This is the table that contains the day-to-day transaction of the organization. This is the table that contains the day-to-day organization. But what about the other details? Is it not also a fact table? Yes, it is also a fact table. It is also a fact table. But in this case, we cannot afford to have two fact tables. If we have two fact tables, that means we are working with another schema. So we have two types of schema. We have the star schema and we have the snowflake schema. We have the star schema and we have the snowflake schema. One is more effective than the other. Star schema is a centralized kind of modeling, whereas a snowflake schema has a kind of step-by-step, like a kind of departmentalization scaling. That's multiple tables, multiple dimension tables are connected together, and this affects a lot of things. It creates redundancy, it affects our query speed. Our visualization will be low. For example, if someone has used a star schema, another person is using a snowflake schema, and you have done a very good job, but you're using a snowflake schema. The rate at which your presentation is going to load is going to be slower because there are a lot of redundant data you don't even need in the first place that in your data model that you need to deal with. So after identifying all of this, I can see that these two are fact tables. So why should I have two fact tables? Why don't I just have one? So before I do that, I'll first see, okay, my table is fine. I'll check my types, my data type. So for the category ID, though it is a number, but I do not want it in number because it's actually an ID. The data column or the data type that you want to leave in number, they are the ones that are measurable. In this case, though category ID is a number, but it's not measurable. It is not measurable. So I believe you understand what I mean by it is not measurable. If you do not understand it, please write it down. At the end of the session, I will explain it. So in this case, I'll just change it to a text data type. I'll replace current. Then I'll move to the next one. Okay. I think all the data types are correct for this. And then employee. I'll change this to a text. Yeah, replace current. Other ID, I'll change it to a text. Replace current. Product ID, I'll change it to a text. Change it to a text. So, okay. Other details, other ID, I'll change it to a text. Employee ID, I'll change it to a text. Shipper ID, I'll change it to a text. So my product, I'll go to my product, change my product ID to a text too. Category ID, I'll change to text. My shippers, I'll change the ID to a text. Yeah. So since all of my data are in the right data type now, so the next thing I want to do is I'll just go back home and close and apply. I'll still come back to my Power Query, but I'll close and apply first so that we can see what our data model looks like. So I have loaded my data into Power BI. And the next thing I want to do is to go to my model view. So this is my model view. I'm going to minimize this. I'm going to minimize this. And I'm going to reduce the zoom so that we can see very well. So this is what our data model looks like. This is what our data model looks like. And we can see that what we have here is a snowflake kind of modeling. What does it mean? Many dimension tables are being connected together. The other table is supposed to be the fact table, but there are some other, like the other details table is also connected to the other table, which is the fact table. The product table is connected to the other details table. Category table is connected to the product table. So we have a lot of connections that may slow down our query. we have a lot of connection that may slow down our query. So what can we do? What can we do to ensure that we have a centralized fact table? There are times that we have multiple fact table. I'm not disputing that, but in this case, it is unnecessary. It is unnecessary. So we can see what our data model looks like. We can see what our data model looks like. So I'll go back to my Power Query. Okay. I'll go back to my report view. Then from there, I'll right click or left click depending on how your keypad or your mouse is working. Then in my Power Query, I'll come to my other details table. And other details, I want to filter my table. And I want to see this, only this one. I want to check, select all, see only this one, and click on OK. And I can see that in my other details table, this is repeated. It's 01248. Okay. I'll cancel the last step for that. I'll come here to check my other details. So my other ID, this is just one. It's just one. That means there's no repetition here. If I check another ID, I'll cancel my last step. I'll check another ID. On select all, I'll check this one. So it's obvious that this table does not have duplicates. Then I can go ahead and use my view option to check my column profiling. And I can see that the distinct and unique are the same thing. So there's for this my other ID. And for this my other details or other table. So if you look at the feature of this table, we have other ID, customer, other employee ID, other date, required date, and the rest of them like that. We have all of this there. As if we have all of this here, and in our other details table, we also have all of this information. We have order ID, product ID, unit price. So the best thing to do in this case is that my order table has all of this information, but it does not have duplicates. It does not have duplicates. My order ID has all of this information, which I'll be needing in my order details table. Of course, for me to analyze this data, I must get my unit price. I must get the quantity and the discount I'm giving on each product. I must get it, but it's not in my orders table. So the best thing is, why don't I just look for a way to combine these tables such that my order details table and my order table becomes one. My order details table and my orders table becomes one. So what I will be doing is that I'll be merging my table. I will be merging my tables. So I'll go to my order details table and I'll go to the home tab and so what I'll be doing is to come here and make sure I scroll, depending on the font size you're using, I'll come to merge queries. And I'll come to merge queries again. I have two options of merging. I can either merge my queries or merge as new. I'll be using the merge query option. So I'm going to merge what is in my order details with what is in my orders. So I need to look for a unique ID that connect these other details with my orders. And the unique ID that they both share is the order ID. So I'll click on order ID here, click on order ID here, and I'm doing a kind of join. So this joining I'm doing is the left outside join. Don't worry about the type of joins. By default, Power BI is going to choose the right type of join for you. Then once I click on OK, I've been able to join my two tables together, my order table and my order details table. So I need to expand these tables. So expanding this table, immediately I join them, it will just come as table, 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 table. So I need to click on this and I need to expand it. So if I want to expand it, what do I want to do? I have my order details in this first table already, order ID in this first table already. So do I need to bring it in again? No. I will uncheck the order ID. I will also see if there's another thing I need to uncheck. No. Then I want to uncheck use original column name as prefix. I don't want it. Then I'll click on OK. So what has happened now is that I have been able to bring the information in this table and the information in this table together as one. So now instead of having it as a separate table, I'll have just one table that contains the information of these two tables in one. So now what I need to do is to come to my orders table and I'll right click or left click depending on how my keypad is working. Then I come here and I can see enable load. What do I want to do? I want to uncheck enable load. It's telling me there's possibility of data loss, but I'm sure of what I'm doing, so I'll click on continue. So what I have done here is that I have been able to combine these two tables together. And because I have combined these two tables together, there's no need having this table. So your work as a data analyst also is to, at the back end, which is the Power Query or whatever back end you are using for your data cleaning, you want to remove, you don't want to show the user the data that you have removed or the ones that you have not using. So the essence of this, or the importance of this, is that once I go back to my Power BI now, you will not see other tables again. What you are going to see is the other details alone. Because I combined these two tables together, I do not need to see the other tables again. The details I need is already in the other table. So another thing is I need to check these two tables. Like I mentioned before, yeah, in my model view, my order table is connected to my order details table. And what is connecting them, maybe I should explain what was connecting them is the order ID. Immediately I click on this arrow here, I can see that it is the order ID that's connecting them. So I was able to see that the unique identifier between them is the order ID, and that was what I used to merge them together. That was what I used to merge them together. Then another thing is I noticed that my product table and my category table are also connected. What is connecting them? The category ID. So I may want to check my table view here to see my category table has category ID, category name and description. Then my product table has product ID, product name, quantity per product, unit price, discontinued category ID. And I can see that my category ID here has duplicates. But in my category table, it is just one. The same thing I did to the other ID and the other details I did, the same thing I'm going to do. I'm going to merge the queries. And why do I need to merge the queries? Why I need to merge the queries is because I have found out that this my category ID does not have duplicates. But when I come to my product table, I can see that my category ID here has duplicates. Yes, it has duplicate. I can decide to have them separately. But because I want to have a star schema modeling, which is more efficient than Snowflake, I'm looking for a way to bring these tables together if it is necessary. Please keep that. If it is necessary and if it is possible and if it is important and it is reasonable for me to do so. So I need to understand my data sets. I understand that I'm sure of what I am doing. So in this case, I also realized that, oh, why do I need to have a category table and a product table? So what it means is that in this case now, this is the product table, right? In this case now, for all the products, for this product now, they belong to, for example, chai belongs to category 1. And category 1 here is for my category table. Category 1 is beverage. So why don't I just combine the product table? Why don't I just combine the product table and the category table as one and give it maybe a name like product category? Instead of having a category table separate and having a product table separate, and I have a kind of decentralized model. So why don't I just have one fact table and have multiple dimension table that connects to these fact tables? Like that connects to this fact table, I mean, many dimension tables connecting to this fact table. That is the purpose. So you must understand your data set very well. You must understand what you are doing, if it's reasonable and if it's achievable and if it makes sense to do so. So in this case again, I'll go back to my Power Query and I'll go to my category table. I'll go to merge queries, and I want to merge my category table with my product table. And the unique identifier I'll be using is category ID. Category ID, and I'll click on OK. So I'll expand it to, I'll click here and expand it. And since I have my category ID here, I will uncheck it from here. And I don't want it to come again. I don't want to have to. I'll click on OK. So I've been able to combine what is in the product table and what's in the category table together. So I have one table and I can rename this my table as, I can either rename it from here or from here. And I can call this product category. Or products and category, depending on what I want to call it. I can call it products and category. And I can just, and the same thing, I'll come to my product and I'll right click and I'll uncheck enable load. That means I have disabled load. Yes, I'm sure of what I'm doing. I'm not afraid of data loss. So that is what I've been able to do here. So for these other details, I can leave it as other details and I can just rename it to as others. Let me do the renaming from here. So I can either rename from here or from there. So now I've disabled others. I've also disabled products. So now I have this. So now when I go back and I go to close and apply, so we can see that now I have, instead of having 7 tables, I now have 5 tables. And the essence of all this is that now I do not need, okay, now when I go back to my model view, I'm going to reduce the zoom so that you can see it. I can see that I have a centralized modeling. So my other tables, I mean the dimension tables are now connected to my fact tables. And I do not need to have like other dependencies. I do not need to have a dimension table connecting to another dimension table and like that. So what we have done here, we have done data normalization. We have cleaned our data. We have transformed our data. We have removed column. We have merged queries. And we can as well do a lot of other transformation based on the need of our data set. But the essence of this class is to be able to identify which is a fact table and which is a dimension table. Is there a reason for merging? There may be other reasons for appending your tables. So in this case now, we merge our tables. There are times that you need to append your tables. And the difference between merging tables and appending tables is that when you're merging tables, you are combining tables side by side. You are bringing one and putting another beside it. But when you are appending table, it's like you're joining tables, like you're doing a kind of stacking, up and down stacking. Up and down stacking, like you're putting one on top of the other. That's appending. But by merging, you are doing a kind of joining side by side. You are expanding. Most of the time when you are merging, you are expanding the columns. But when you are appending, you are expanding the rows. You are making your rows longer. So that is the difference. So I've explained what a fact table is. I've explained what a dimension table is. I have explained what a primary key is. I've explained what a foreign key is. I've tried to show us the view column to know what the characteristics that we can use to differentiate between a fact table and a dimension table. So the essence of this class is just for data modeling. We are not going into analysis, we are not going to measures, we are not going into other type of cleaning. It's just to know how to model our data. Just to know how to model our data. Know how to model our data. So we have been able to model our data. So from here now, I think I've done justice to this topic. I will be stopping the recording so that it can be useful on our YouTube channel. So after that, we can start asking our questions. If you have any question, please ask. And I'm going to